This is my Module 3 on path analysis, and this path analysis that I conduct will be compared and contrasted against OLS regression of the same variables. So before I could do any of these things, I first had to get variables. So I have here x1, x2, x3, and y. x1 being sport preference, x2 being time taken to run 100 meters among the given participants, x3 being sports performance, and all of these trying to predict the heart health of our participants with our variable y. So first, because x1 is a sports preference, I decided to code it with effects, because with path analysis it is far better to use effects coding than dummy coding. And in this case, I used a variable with 6 categories: baseball, basketball, football, soccer, hockey, and volleyball. And as we can see, the base comparison group is volleyball, as it's delineated with a -1. And as you can see, compared to dummy coding, the zeros here are implicit. So I ran an initial regression on these variables, and as you can see, all of our categories in x2 are non-significant when regressed against y. However, x3 is significant. And then when we run x1 and x2 on x3, we have significance all the way down. This helps to show that there's some sort of type of mediation going on, in that x1 and x2 have a causally significant relationship with x3. However, x3 then has a relationship with y. So we can see that there's a causal pathway starting to form. I decided to run diagnostics on this regression to make sure that it was sound, that there were no real issues. And as we can see on the left, we have normally distributed residuals around a mean best fit line of 0. So that shows us that those assumptions are met, as well as it can also point to the fact that we have homoscedasticity. Additionally, Cook's distance, our Cook's distance plot here, it looks pretty good, actually. We have no points or outliers that seem to be unduly influencing the rest of the model. And if we keep going, we have a normal QQ plot, which once again shows us that we have very good homoscedasticity. The line is almost completely straight. However, when we look at the correlation matrix, we can see that x1 and x2 both are highly correlated with x3. Now, this is an issue because with regression, all of the variables that came before that are being regressed upon y, especially x3, has significant pieces of x1 and x2. And because of that, we can't really deduce the exact individual effect of each one on our y outcome. As a result, I've used path analysis, because path analysis will better allow us to identify the direct and indirect effects between each predictor variable. And this is important because Friedman 91 said that your measurement model needs to be justified by your theoretical background. And in this case, with the variables we use in the situation we're in, we are justified in using path analysis. Additionally, once we run this path analysis, as we can see, I've run x1 as a continuous variable within the path model, because as I found a source as I was researching path analysis that stated that if you have a variable with 6 or 7 categories, you are justified in treating that variable as continuous, because the results of running it either way came out basically the same. That citation is Remtula et al. 2012, and I've put a little reference section at the end where you can look at it more specifically. So, after running this path model, R has given me these 5 little cutout diagrams. I'm going to go over each one individually, because each one is important to understand the degree of model fit that we have, and the more our model fits our data, the better. And I'm going to go over the series of regressions that are included as well. So first, we have on this top left here a chi-square test where our p-value, as we can see, is 0.497, which is actually a good thing because model fit needs a non-significant chi-square. In this case, we have a 0.5 where for it to be significant, we would need a 0.05. However, for the rest of these, the opposite is the case. We want less than 0.05 for RM, SEA, and SRMR. And as we can see also, they are very much fitting that requirement as well. And finally, we have CFI and PLI, where the larger these two indexes are, the better your model fit is. And in this case, the maximum value you can have is 1. So the fact that we have 1 for both of them is extremely significant. However, I caution using those two because I'm not sure what R uses as a baseline model. I only have mine at the moment. So I am going to take those results with a grain of salt. But with the other 3 tests showing very, very good, in fact, excellent model fit, I'm willing to accept that our model has done really well with our data. Now, moving on to the more significant part, which is our regressions. Path analysis is a form of, it's a kind of constructed form of SEM, and SEM is just a large series of regressions. So, as I just said, R has given us regressions where X1 and X2 are on X3. It has also tested the interaction between X1 and X2. And it also has regressed Y on, or X3 on Y. As we can see, all of our p-values are significant. Our R squares are really high. And this is typical, this almost perfect model fit and the significance of the pathways that we want to be significant being significant is indicative of the fact that I've created these variables. So I've created these data for the model, and the model came back, and it kind of shows the success of our path analysis because the model came back exactly how it was originally designed. And I'm saying this to show that with actual data, this will definitely be a different story. And to further illustrate this point, R has come out with, I also used R to plot our hypothesized model. And as we can see, there is a non-significant interaction between X1 and X2, which is exactly what we want. There's a significant pathway between X1 and X3 and X2 and X3. And the two of those lead into X3, and then X3 then leads significantly to Y. So we have a sound causal pathway with path analysis. And one last final point that I would like to note is from Olin and Hauser, 1975, in which they mentioned within their paper that when an exogenous variable has an effect on the dependent variable, which is our Y, through another exogenous variable, as we can see here, X1 and X2 going into X3, then to Y. And it is said to be that X1 and X2 have a measurable indirect effect on Y. And their paper further delineated how to calculate that indirect effect using the coefficients presented earlier, our B values within the path analysis. Lastly, I wanted to show you the reference that I used, where it's when can categorical variables be treated as continuous? Very obvious. And you can check that paper out as well to further understand where it's coming from.